Trigonometry with right triangles. Consider a right triangle that has an acute angle theta. Here it is. Hypotenuse is the longest side that is opposite the right angle. There's the hypotenuse. The opposite side is the leg that is opposite the theta angle. So that would be, here's our theta angle. So it would be opposite that. That is the opposite side. And last, the adjacent side is the side, the leg, I should say, that is next to theta. Because the other one would be the hypotenuse. Now the symbol theta you're going to be writing a lot, so I recommend practicing it. Usually people will make a circle and then a line through it. If you want to be fancy about it, you make a circle then with like a little squiggly. Just practice that a lot. 30 minutes a day, you'll be good in no time. All right, here's some trigonometric functions and their abbreviation. We have sine, cosine, tangent, cosecant, secant, and cotangent. And you see they're abbreviated to 3 letters. And then here are their definitions. Let theta be an acute angle of a right triangle, which we see in the drawing up there. The trigonometric functions are defined as follows. So sine of theta is the opposite side divided by the hypotenuse side length. Cosine theta is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. Below that, you see we have cosecant. And notice that those are just reciprocals. So cosecant is the reciprocal of sine. So cosecant of theta is the hypotenuse divided by opposite. Or you could also say that cosecant is 1 divided by sine of theta. To remember the 3 main ones, and you probably have those buttons on the calculator, sine, cosine, tangent, that have always been staring at you, and you've been wondering what they are. You can use the acronym Sohcahtoa. I'll say it again, Sohcahtoa. That will help you out a lot, and let me show you how each part's related. The So part represents that sine S is the opposite O divided by hypotenuse. So that goes with that one. Ka, C-A-H, means that cosine of theta is the adjacent divided by the hypotenuse. And Toa means that tangent of theta is the opposite divided by the adjacent. Let's use that to evaluate the 6 trigonometric functions of the angle theta for the triangle we see there. So we have theta marked. Sometimes I also just like to put a so we'll mark the angle that way too. And first thing we should write, identify what each part is. So we have the hypotenuse, which is opposite the right angle. And then the opposite side is the leg that's opposite the theta. And finally we have the leg that's next to the theta, that is the adjacent side. Let's also write down Sohcahtoa, because we're going to be referencing that a lot, and it will help you memorize the trigonometric functions. All right, so means that sine of theta is opposite over hypotenuse. There's cosine and tangent. Now we already have the opposite and the adjacent side, so we could do that last part. We know that since tangent is opposite divided by adjacent, that would just be 15 divided by 8. To get the other ones, to get sine and cosine, we need to find the hypotenuse. And to do that, we use what was the answer almost every single time when a teacher asks you a question in grammar school, later on in grammar school. Pythagorean Theorem. So a squared plus b squared equals c squared. We know the legs. We're looking for the hypotenuse, which is c. We get 289 equals c squared, and we take the square root of both sides. We get that c is 17. So hypotenuse is 17. So now we can go ahead and do the other parts. We know that sine of theta is opposite divided by hypotenuse, so opposite is 15, and hypotenuse is 17. So just pull the numbers from there. Cosine of theta, adjacent, that's 8. The hypotenuse, still 17, and there it is. So I could write those down a little bit neater. There they are. And then the other 4 would just be the reciprocals. So cosecant of theta is 17 over 15, secant of theta is 17 divided by 8, and cotangent of theta is 8 over 15.